Hey, boys and girls, we are back talking more lines of symmetry. So last week we talked about folding and just seeing if the shape has symmetry or does not have symmetry. Today we're going to talk about how many lines of symmetry it might have. Okay, so you can still use your reference sheet. It will be up and posted. But remember, a shape has lines of symmetry or a line of symmetry if it can be folded about a line so that both sides are exactly the same. Okay. And we talked about vertical lines, horizontal, and diagonals. I will also go over, let's see. I'm going to record this tab now. So bear with me. Okay. All right. So let me see if I can. Oh, here we go. Here I am. Okay. So this is yours for today. So you're going to drag, and remember the directions are right here. How many lines of symmetry does each figure have? So you're going to drag the pieces to it. Okay. We're going to do some practice with how many lines of symmetry things would be. Okay. Some will have 0 lines of symmetry. There might not be any line of symmetry for it. This one, you're going to figure out how many lines of symmetry, and then you're going to move the circle over it, whatever one you think it is. And remember, you could stretch out that circle. That's fine as well. And then the last one is a true false. So figure C has an infinite, meaning goes on forever and ever, number of lines of symmetry. So you would look at figure C. What do you think? Figure B is not line symmetric, so it does not have any lines of symmetry. Take a look, true or false. Figure A and D have the same number of lines of symmetry. So A and D, do they have the same number of lines of symmetry? And figure E has more lines of symmetry than figure D. Okay, true and false. So you're going to move the blue circle over whatever one you think it is. Let's try some now. Okay, so behind me, I have some shapes. Now, we've talked about all these shapes in this chapter. So we have a triangle, a square, a parallelogram, a rhombus, trapezoid, and a hexagon. Okay, so what we're going to do is we're going to look at the number of sides and then how many lines of symmetry it might have. So the triangle has 1, 2, 3 sides, and it has 3 lines of symmetry because I could do it like this. I could also go this way, that's 2, and this way, 3. So it has 3 sides, and it also has 3 lines of symmetry. Take a look at the square. So I could cut it right down the middle, right, vertically. I could cut it horizontally, and it would be the same. I could also cut it diagonally, and it would be the same. So right now that's 1, 2, 3, and 4. So it has 4 sides and 4 lines of symmetry. Now, it doesn't always mean if I have the same number of sides, it's going to be the same lines of symmetry, and I'll show you why. Let's take a look at a parallelogram. It has 1, 2, 3, 4 sides. But if I cut it this way, these are not the same. If I cut it across, they wouldn't be the same. And up and down wouldn't be the same. So there is 0 lines of symmetry with a parallelogram. Let's take a look at a rhombus. Now, bear with me because my drawings aren't as clear as what like your picture would look like. If I tried to cut this across, it doesn't have this lines of symmetry. Rhombuses have 4 sides, and it should be a little bit more. My rhombus almost looks like a square to me, but remember, rhombuses have 4 equal sides in length. Bear with me on my drawings, guys. But okay, so if I did a rhombus, I could cut it this way. That would be 1 line of symmetry and 2 lines of symmetry. But if I cut it this way, it would not be the same. And if I cut it this way, it would not be the same. So it has 2 lines of symmetry. A trapezoid has 4 sides. If I cut it going down, that's 1 line of symmetry. And that's pretty much it, because if I cut it going this way and tried to look at the fold, it wouldn't work. And this way wouldn't work. So really, it just has one line of symmetry. And then a hexagon